India is moving towards developing supercomputers. C-DAC has got the responsibility for this. I'm Piyush Pandey and C-DAC Director General E. Mangesh with us, who will tell by when India will get the indigenous supercomputer. Sir, my first question is that what progress has been made so far towards making indigenous supercomputers?
Okay. First, let me explain what are the components of a supercomputer. It has got three components. One is the processor itself, and then you make the motherboard using the processor, which we call it as a node, as a single node. And we make multiple of such nodes and interconnect them to make a cluster. And that cluster is called as high performance cluster or supercomputer. That is the definition. Apart from these nodes, there are interconnecting wires which connect all these nodes. We call it network interconnect, or we, in general terms, it's called Ethernet connectivity or InfiniBand or such thing. And then third component is the storage. So what we are talking about is the compute, the networking, and the storage. These three forms the key elements of any supercomputer.
Okay.
In the last few decades, C-DAC has contributed immensely on the networking area, which we call as ParamNet, and today we call it Trinetra A, B. We have moved to different generation of this network card, which we call it Trinetra A, B, and today we have B+. And then from the storage side, we have built our own storage server and accelerator for the storage. It's available. And on the node front, on the compute node, when I spoke in the earlier point, so this is a basic unit. Today we are using x86 based architecture, and using those
Okay.
chipsets available in the market, we have built indigenous server nodes. So this is being manufactured today by few companies, few EMS companies in the India, like VVD and Keynes. These are companies who are already started manufacturing it. Some companies have taken TOT of this technology so that they can manufacture and serve other requirements of the country. So
Okay.
as told, three components are done already. System we have done the networking, we have done the storage. Using all of this, we create clusters. So these kind of clusters are available today in the country. A POC is done in our center in Pune. A small machine is available in C-DAC Delhi, which is like 100 teraflop. And then we have a larger machine, which is to be launched. We are expecting PM to inaugurate that in the coming months, and we'll have a big event on that. So that is about 3 petaflop. So this is one of the biggest machine that we have, which is
Okay.
indigenously manufactured and built in the country. So the only
Okay,
missing
sir.
piece here is the processor chip that we are using off-the-shelf component, the
Yes,
x86.
my next question for that actually, and uh, yesterday, may CDEC take cooperation to develop high capacity processor. Which
Yes.
companies are those, and what is the plan of CDEC for the processor?
So for the processor, so we need multiple cores of the processor to work together to make a high-performance computing chip, actually. So
Yeah.
today the trend is moving towards low power. So when you talk of low power, there's one company which is giving the best performance and the power consumption as well, and that is the ARM architecture. So we have licensed the ARM technology for this purpose, and we are using it to build this processor, which will have multiple of this. So we are targeting about
Okay.
96 cores to go into one processor. So our first partner is the ARM, UK-based company, ARM. So we have licensed the ARM technology from them. And then we identified a consortium of companies who can come together and work with us to realize this processor in a silicon form. So today,
Okay.
as you know, we have to get it manufactured outside the country, like TSMC, UMC, or other foundries, because we are yet to have our own foundry in the country. So we need the interface to can talk to them and get the best technology to us. So the best technology that is available worldwide is the 5 nanometer technology. So this
Okay.
5 nanometer, we go to these consortium partners to reach out this to foundry and get this fabricated.
Okay.
Prior to that, we have to put together the design. So we have to combine this processor cores, multiple of them, say 24 clusters, 48 clusters, and make a 96 cluster, 96 core processor. To make this happen, we have found an Indian partner. We wanted to do that within the country. We wanted to do this, the whole design and implementation within the country. So we were very much for any Indian company to come forward and make it happen in the country. So our expression of interest was made such a way. The lead company should be an Indian company, and
Okay.
they could
Okay.
have partners sales. They can have partners outside the country to get it fabricated, tested, and all that. But the design should happen within the country along with the C-DAC scientist. So that was our
Okay.
first intention. So therefore, we did this expression of intent, and then we've identified this partner, who is none other
Okay.
than MosChip Technologies, who is Hyderabad-based company. They also have very good history of successful chip designs. They were originally a product company. They've done a lot of control Ethernet controllers, and they went into market, and they are good, doing very well. So we engaged with them, and through them we reached out to their partners called Socionext. So this is a
Okay.
Japanese company who, so they were also part of such kind of designs in the past. So they worked in big designs like this. So with their support, this consortium came together and they were the best, and we selected them. And in the next
Okay.
2 years, we are expecting a first milestone, which would be the tape out of the chip. The tape out of the chip means the design. We are completing the design and ready for fabrication. That's the meaning of tape outing of chip.
Okay.
So
Sir, my question related to next actually issue. There is any timeline when will the indigenous high capacity processor be prepared in India? There is any timeline?
yes, sir, there is a timeline. First, we have to go stage by stage. So the design and development is one stage, and the fabrication is another stage. And finally, there will be a testing, and then you do evaluation of the chip, which comes back to us. So there are 3, 4 steps involved in this making. So this is the first time that we are putting together 96 core. The design has to be done right at the very first time. There is no scope of making any mistake. We can't afford any respin, or we can't avoid different versions year and after. So with all caution, we are going to this design cycle so that whatever we do on the drawing board, it's fault free and defect free. So we are very cautious. We take more time on the drawing board. Therefore, we need at least 2 years to make the design and the implementation done. That would be
Okay.
in 26. We will have this design done and ready for fabrication. And the design files will be sent abroad, which is TSMC, through our consortium partners, and they in turn will get this manufactured at TSMC. Normally, for TSMC or UMC, which is offering this node, they take 4 to 6 months to fabricate because there are a lot of steps involved in the fabrication. First thing is they do mask preparation. They create multiple layers of mask wherein they use the lithography process to make your chip, multiple chip. And then once that mask design is done, they actually use the mask to fabricate the chip. And then subsequently, the dye level testing will be done, and then it will be packaged. And again, the package also will be made, go through a complete testing process, and then it gets shipped back to India. So that process itself is a 1 year, 9 months to 1 year time after we deliver the design. So we are talking of
Okay.
a timeline of about 3 years. Until then, we need to wait till the chip comes back to the country.
Means 2027. And
Yes, yes, in
so my
27.
next question related to position of technical field in India. Basically, what position will India hold in the field of computing globally after manufacturing indigenous supercomputers?
So with this particular processor design and the lot of efforts which has already gone into making the supercomputing clusters, we are actually the fourth worldwide. We're the fourth country in the
Okay.
world to take up this, and there is no other country. I mean, America, of course, there's European Union, the Japanese country is also involved in this. And then we are the fourth country in the world to venture into this making supercomputing chips.
Okay, sir. And last question is that what is the C-DAC plan? And how much time will it take to implement it? Means when the supercomputer prepared in India
So as I told, once the process, that is a 3 year turnaround time. Once we have
for
the
processor.
processor, it is about putting that processor into motherboards and building clusters, manufacturing multiple nodes and clusters. So that is, we can do it within 6 to 9 months, we can complete. So 3.5 years to 4 years, we'll have our own full-fledged clusters up and running, which we call, Atmanirbhar Bharat, the fully self-reliant system for the country.
Sir, there is any cost efficiency when we prepared supercomputers in India?
Yes, definitely there's a cost advantage is there, because we are not paying additionally, because there are a lot of IPs, which is homegrown IPs, which is going inside the processor. And we have already brought this IP. There is a small royalty need to be paid to the ARM whenever we manufacture, a very negligible amount. And we have the complete manufacturing of the systems within the country. So that's a big saving. Instead of buying and keeping, we build our own, we design, we build our own system, manufacture our own system. There are a lot of savings involved in this. So, and of course, because it
Okay.
is an ARM architecture, there's a lot of power savings. So the x86 processor, as it is a complex instruction set architecture. Because of that, it consumes a lot of power. Whereas the ARM is a reduced instruction set computing processor. It is power efficient, and therefore we save a lot of power. We don't need to put big power plants to run these machines. So in fact, it can run 50% of the power that is normally required.
So my last question is that, ISRO, that chosen name of Chandrayaan 3, Chandrayaan 2, Mangalyaan, uh, do any name chosen by C-DAC for future processor which prepared in India?
So actually, as you see the backdrop, what you have, we wanted to have a digital India RISC-V roadmap, what we called as RISC-V DIR-V program. So the
Okay.
supercomputing processor, today we're talking of ARM architecture. And for going forward, we will have our own architecture, which is called reduced instruction set architecture version 5, that is called RISC-V. Our Honorable Minister has made it, calling it as DIR-5 processors. So we'll have, going forward, we'll have a series of DIR-5 processors coming up, which will be much more efficient than what we are doing today.
Okay.
And the idea is to have it fabricated within the foundries coming up in India. So we'll have new chips coming in the 28 nanometer fabs that is upcoming in India. So this next
Okay.
generation processors will be based on that.
Okay, sir. Thank you so much.